No, I'm not recording. Number 8, write two situations that can be modeled by a function whose values change at a constant rate per unit of time. So this is any kind of a slope problem. So one example, think of anything that has a per in it. So like I make $4 per hour. Okay, so if you have a constant rate, then it is a situation that's linear. Can anybody think of another per? What's a situation that has a per? When do you use per? Per mile? What kind of per mile? Drive at 50 miles per hour. Anything that has a constant rate and each every year a per is a linear function. What is the correlation coefficient of 1? Okay, these are dots that go like this. You draw those dots. Correlation coefficient of 0 is all over the place. Correlation coefficient of -1 looks like this. What is something that increases? So like what makes a plant grow? Okay, the more water, okay, water versus plant heights. Okay, so when you give a plant more water, it makes the plant grow. What makes a plant die? No. Let's say temperature drop versus plant height. Okay, temperature drop. So when the temperature goes down, the plant height goes down. So this is a cause and effect where they're positively correlated, more water, more plant height. This one is negatively correlated. So when the temperature goes down, the plant height goes down. What are two things that don't have anything to do with each other? What doesn't have any effect on plants? Baseball score versus plant. Okay, the score in the baseball game does not affect the plant height at all. So that's not a correlation. So this is positive correlation, one thing goes up, the other thing goes up. This is negative correlation, one thing goes up, the other thing goes down. This is no correlation. One thing does not affect the other thing. Okay. Amanda got paid an hourly wage at her job, but increases if she works over 40 hours. If the number of hours she worked last week represented as this thing, what is the hourly wage before overtime? Okay, so let's look at the structure. We were talking about hours, right? So that's 10 times 40. This is the hours, and she must make $10 per hour. What's her new hourly wage, the multiplier? 25. So she used to make 10, now she makes 25, and this is the number of overtime hours, the number above 40. So if she had like 45 hours, then that would be 45 minus 40, that's 5 hours of overtime. Okay, so the hourly wage before overtime is $10. How much does she get paid for 40 hours? We did this. 40 hours for 10 hours, or $10 for 40 hours, $400. How much does she get paid per hour for working overtime? That's the multiplier over here, it's 25. What's the total amount she got paid including her overtime? I'm going to say it depends. It depends on how many overtime hours you work. Yeah, that's fine. This particular question that last question is not on the final. So if you worked 5 hours of overtime, that would be $10 an hour plus 25 at $5 for 5 hours. It doesn't tell us how many hours she worked all the time. Okay. Okay, this one is basically impossible. Skip this. Mr. Wolf will in my opinion, this problem is impossible. Skip it now. Well, you're not gonna, I mean, it's just I could teach it to you, I just don't think it's valuable time. So skip it, I'm gonna delete it when I grade the final. Basically, you would have to take this equation, figure out what the slope is by solving it for y, and then use slope, figure out what the slope is for these two, and it's really pretty gross. Okay, next page. Let's figure out, I'm going to figure out where it starts, which is at 0. Where does it start? Don't say 5. No, okay, in the function 5x minus 3, where does it start? No. Guys, in 5x minus 3, what is the star where it starts? -3. Okay, so I'm going to put it right there. That's where the 0 is. And then it's going to change by 5 each time. So the next one's going to be 2. How much if I add 5 to the next one? 7, 12. Okay, let's work backwards. Now I'm going to subtract 5. -8. Subtract 5 again. -13. That's my table. Okay, so I'm going to take those values, I put them in that graph. What kind of a function is this? It is a linear function. Why is it linear? Because it's mx plus b. How did I do that? I started at -3 and it changed by 5 each time. Okay, number 14. Functions f of x and g of x are represented where are they equal to each other? They are equal right here. Please don't curse. And right here. Okay, so let's write they are equal f x. F of x equals g of x where the two lines intersect. Where does that happen? It happens at 3, 0. And what's this other one over here? 4, no, not 5, -5. 4, -5. So the two solutions are 3, 0 right there and 4, -5 right there. That's where the two lines intersect. Next one, I always draw a function diagram when I have a function word problem. So here is my function diagram. Okay, so when I see a function word problem, it's got a function because it says h of t, and I want to know what the notation means. I always draw this picture. H of t goes in the middle. Now I need to know what h is and what t is. T is the input. T goes in, h comes out. What's t and what's h? T is for days. H is for the height of the sunflower. Okay, so what does h of 45 equals 7 mean? That means you input 45. You output 7. Okay, so it means after 45 days, the height is, so t days, 45 days, the height is, after 45 days, the output is, okay, if you input 45, the output is 7. And it doesn't give us unit, it must be 7 centimeters. What if it was 65 days? So that's h of 65. So that's input 65, and you get out. Write a statement using function notation to explain that after 65 days, the sunflower will be 11 centimeters tall. So the height of the sunflower after 65 days is, okay, the sentence says the height after 65 days is 11 centimeters. We are going to turn this statement into function notation. The height at 65 days is 11. Yes, thank you. I'm glad. That's going to be on YouTube now. Okay, we got one more. Okay, I'm just going to show you how to put these into the calculator. So where the t is, I'm going to put 2, 4 times 2 minus 7, put that in the calculator. Do not forget the parentheses. So negative 3 squared plus 2. I'm going to say don't forget parentheses. And then the last one, I'm not going to forget the parentheses either. Negative 14 minus 3 parentheses. What goes in there? Good, I'm glad I'm going too fast. What goes in there? Okay, this is the one that was backwards. You're going to use algebra. So I know the output, but I don't know the input. I need to know what t is going to make this true. Okay, so that is the next 2 pages of your notes, and good luck with the remainder of the test.